Hello students, welcome back. Let us start with a new topic of chapter 13, that is surface area of right circular cone. Just like we learned for right circular cylinder, we are going to learn about the curved surface area and the total surface area. So first of all, what exactly is a right circular cone? If you go to draw it, it would look something like this. Or you could even draw it this way. So how exactly can you define this geometrical figure? That it is pointed at one side, and as you gradually proceed to the other end, it is flat circle. Okay, so this is what it will look like when you look at it from the rear side, and the base would look like a circle. So how exactly this cone is formed? Let's say I have a circle. So if you cut out a circular sheet of paper, okay, and now let's say this is the center. So at the center you draw two radii like this, and you cut out this radii. So when you cut out this piece of paper, so what are you left with? And when you join these two edges, you will get a cone. So let me give you a demonstration. This is like a circle. This was a circle. I cut out the radii, two radii section like this. So I cut out one sector, and now when I join these two edges here, what I get, it is a right circular cone. So it is pointed at one end and circular at the base. So let's say this is the base, okay, and it has, so base is what? This region out here. So let's say this is the base that is cut out, and it has some radius equal to L. Okay. So, and over here, rather let's say the radius is R. Okay, so this was about the base. Coming back to this section now. So in this section, let's say I cut out different triangles, such that the base over here, I'll cut out infinitely many small triangles, such that each of the base of the triangle is flat. Let me call this base 1, this as base 2, this as base 3. So you can see for this triangle, this is the base. For this triangle, this is the base. For this triangle, this is the base. So like this, you will have n number of triangles with n bases. Okay, see, now the height for these triangles is going to be the same. So let us call this height as L. Height of this triangle to be L. So this is the height. Now, so what is the area of each triangle? Area of triangle 1 is what? Area of triangle 1 is half base 1 into height, which is L. Similarly, area of triangle 2 is half B2 into L. That's half into base into height, and up to area of triangle N is equal to half B3 into Bn into L. Because this is the nth triangle with having base Bn and height L. So now the area of this entire region will be what? The sum of all these areas, correct? Area of triangle 1, area of triangle 1, area of triangle 2, area of triangle 3, up to area of triangle N. This is your nth triangle. So I'm going to just erase this section. So now please try and understand that this entire section is what? It's the area of your cone. Because what I'm doing is, this cone I'm just flattening it to find my area of the cone. So area of the cone is equal to half B1L plus half B2L plus half B3L up to half BNL. So now if you notice, what comes out common? Everywhere you have half and L common. See. Right? So I can remove half L common. So this is half into L. And what are we left with inside? B1 plus B2 plus B3 plus B4 plus Bn, right? So now we'll keep this half L as it is. How about B1 plus B2 plus B3 plus B4 up to Bn? This is nothing but the base, right? So what is the base? This is your base out here. This base is hollow out here, right? So what is this entire sum going to be? B1 plus B2 plus B3 is going to be the circumference of the base, right? That is this entire thing out here, this entire ring. Everything out here is hollow as I just showed you. So what is the circumference now going to be? We have the radius r. We know that the circumference of a circle is 2 pi r. So this is going to be half L into 2 pi r. We can cancel 2 with 2. So what are we left with? Pi r L. So this is the area of cone. But now we took a look at a hollow cone. It doesn't have a base, right? You do not have a lid at the base. Let's say, so this will be what? This will be your curved surface area. Or CSE. Curved surface area of your right circular cone. Let's say your cone even has a lid at the end, at the base. Okay, so what will be the total surface area? Total surface area of cone will be equal to curved surface area plus area of base. Now base is what? Base is a circle. So this is going to be pi r L plus, now for the area of base, the radius is going to be the same, right? Because here also we took the base of the radius of the base. Here also you are taking the area of the base, so the radius, the radii are going to be the same. You know that area of the base is, first of all the base is a circle, so the area of base is going to be area of circle, which is pi r square. So what can we remove common? We can remove pi common from both these terms. So pi. Also we have r. So r here. Now nothing else is common. What are we left with in the first term? In the first term we were left with L. From this r, r square means r into r. I removed one r, so I am left with another r. So this is going to be the total surface area of your right circular cone. So this is what? Pi r into L plus r. So let's rewrite the curved surface area and total surface area a little neatly so that we can start with the solved examples in the next class. So I'll say curved surface area of right circular cone is equal to pi r L, and total surface area of right circular cone is equal to pi r into L plus r. Now here r is what? Radius of base, and L is what? It's the perpendicular height. So I'm erasing this section now. So this is going to be perpendicular height of the cone. Now let's take a look at our cone once again. This is our cone. It's not actually the perpendicular height, it is the slanting slope. I'll just modify this section. Length of slope. So why do I say length of slope of the cone? If you again take a look at this, see, we had a circle like this. We cut this out. So this was the length, right? So in this section out here, this part is the length. Now what I'm doing it is I'm drawing it like this. So this becomes the slanting length of the slope of the cone. Okay. So now coming back to your cone, this is going to be your L, and this is going to be the radius of the base from here to here. This is the radius, and from here to here is the radius. Okay. So now in certain cases what happens is you're not given this length, but you're given the perpendicular height of the cone. So this is the perpendicular height. Accidentally I had written here the perpendicular height. This is not the perpendicular height. L is the length of the slope of your cone. Okay. So sometimes what happens is you're not given this length, or length is equal to question mark, but you're given the perpendicular height, which is the line drawn from the vertex of the cone to the opposite base, and it's perpendicular to the base. So you're given with this height. Now if you see this triangle out here, or even for that matter this triangle out here, see this length is also going to be L. So you can find out length L using Pythagoras theorem. How? If you can see, let's cut out this section over here, and this is your L, this is your H, and this is R, and this is the perpendicular height. Let me call it triangle ABC. So I have cut out a section of the rear view of your cone to just give you an example of the triangle that is formed. How can I find L? L square is equal to R square plus H square through Pythagoras theorem. Right? So obviously L is going to be R square plus H square, where you know that L is the length of slope of cone, R is radius of base of cone, and H is what? It's the perpendicular height of cone. So when I say radius of base, I'm just referring to R and not R square, and when I'm saying height, perpendicular height of the cone, I'm just saying H. It doesn't mean that H square is the perpendicular height of the cone. So this was about the curved surface area of a right circular cone, the total surface area of a right circular cone. So this was pi r L, this was pi r into L plus R, and just in case you're not given the slanting height or the length of the slope of the cone, you can find out using Pythagoras theorem when you're given the radius and the perpendicular height. So let's revise the formulae that we have learnt until so far. We have learnt about curved surface area of cylinder, which is 2 pi RH. We have learnt about total surface area of cylinder, which is 2 pi r into r plus h. Then we learnt about curved surface area of cone, which is pi r L, and total surface area of cone, which is pi r into L plus R. So these are the two important sections that we have learned. That doesn't mean that we can ignore what we learned about cubes and cuboids, but students usually get confused between these two formulae. That's written. I have written it separately for you for your better understanding. So just make sure that you have these formulae written in the sequence on some page that you're going to refer towards the end while solving your papers, your test exams, just before you actually appear for your actual exams. So this was about it. Please take a look. Thank you for watching this video.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.